let's write the same ancestor tree program in Java that we just wrote in Racket. So remember, we decided our data representation was going to be an ancestor tree is either some sort of sentinel value saying we don't know anything about this person, tick unknown is what I used in Racket, or a child struct with 5 fields. How will we do the same thing in Java? Okay, so, well, if we had a child struct with 5 fields, we're probably going to have the same thing in Java, and we know how to do that. Class child, we have 5 fields. We have string name. We have iColor, I guess, will be a int year of birth. iColor probably uses a string since we don't have symbols. So string iColor. And then field ma and the field pa. And the question is, what type should they be? Now, you might say, hey, use class child. Here's the problem. I can't call the constructor for class child until I have 2 child objects. And you might say, hey, use null. But I don't want to use null to represent data. I can't call methods on null. If I say, hey, I have an empty tree, I want to call it a method on it, toString or size or whatever. Can't call that a null. We've got a null pointer exception. Null is a 4-letter word. Don't use null to represent valid data, like an actual empty tree, okay? So, gosh, how will we do that? Well, we used back in Racket, we used some, tick unknown. Gosh, here's what I'm going to do in Java. I'm going to go ahead and I can't say tick unknown. I could say, hey, I'll use the string unknown to represent the unknown. And then what will I have to have here for ma and pa? Oh, the type of that would be either a child or a string. That's a union type we can't really do in Java directly. So here's what I'll do. I could use any sentinel value I want. Tick unknown is just what I used. I'm going to make a new class unknown. I'll spell it correctly. And now I'm going to say, hey, an ancestor tree is either child or unknown. And now I can put, child or unknown. And these are both types of ancestor trees. How do I say in Java that every child is a type of ancestor tree? Extends. And every unknown is an ancestor tree. Okay, and now I can go ahead and put the type here. This is either a child or unknown. Of course, to get this, if child extends AncTree, unknown extends AncTree, what else do I need? Class AncTree. It's going to be a class with no fields, just like unknown was a class with no fields. But now notice we have all these names as part of Java's type system. It's no longer a comment that an AncTree is a child or an unknown. We actually have that. Java now knows that a child is a type of AncTree and unknown is a type of AncTree. We need to say one more thing maybe at least. We'd want to go ahead and say, what do we want to say about AncTree? You can't be an AncTree unless you're a child or an unknown. You can't just be an AncTree. And the example you may have gotten back in your Java 1 class when they first introduced inheritance was something like, hey, notice that we have class animal and we have subtypes kitty cat and python and porcupine. You can't be an animal without being one of those 3 types. You can't just be an animal. You can't say, hey, make a new animal object. You can say make a new cat object or a new porcupine object. And how do we say that in Java? We can actually tell Java, hey, you can't be an AncTree. You have to be some sort of subtype of that. That's the word abstract. Okay. And if I really, the one thing I haven't encoded is that I want to tell Java, hey, there is no other type of AncTree. There's only child and unknown and nothing else. Yeah, I can't really, nothing's stopping other people from making more subclasses. I wish there was a sealed, some way to say, hey, this class AncTree, all the variants I'm going to introduce right here in this file or in this package or something like that. Java doesn't quite have that, but we'll see another language that does. Scala will have that, Kotlin as well. Okay, so let's go with this. We have abstract class AncTree, class child extends that, class unknown. We can now go ahead and start making some examples of our data. Now that we have our data definition, what are examples of the data? Oops. I'm going to go down here, and I can say things like, hey, new unknown. Yeah, that would be an example of it. Hey, new, make another one. What were examples that we used in Racket? We had a first example was tick unknown. We had Jackie, born in 26, Brown, unknown. Okay, new child, Jackie, 1920. Oh, I'm going to need to write a constructor, won't I? Jackie, 1926, eye color brown, unknown for the mother side, unknown for the father side. New, we know how to represent an unknown child. We say new, unknown, open, close. New, unknown, open, close. Okay. This now is almost word for word corresponding with our Racket code. Instead of saying make child, we say new child. Instead of tick unknown, we'll say new unknown. Okay. Great. Gosh, where's a good place to put this code? This is actual Java code, right? I'm actually calling these constructors of examples of the data. I need to put it somewhere in some class. I guess I could make an extra test class. I'm kind of, some people advise against this. I'm just going to stick it, help to keep things simple. I'm going to go ahead and eventually I'm going to put my tests and everything inside a function inside class AncTree up at the top. It's just a place to put this code rather than making a whole separate class. And I'm going to call this function main. And in here, I'm going to go and take these two lines and put them up in main. Okay. Oh, and this I should probably make this a public method. Public, maybe static. I can't make an object before you call main. Public static. Not going to return anything. I'm just making some examples of the data. Okay, might as well make it take a bunch of strings. Actually, this is where, in your Java class, this is where the command line arguments come from, right? I'm not going to use any command line arguments, so I don't even want to name this arg, so I'm going to go ahead and use a name that is so minimal people won't be tempted to even look at it or read it. I'm going to name it underscore. Except, in Java 8, that became an invalid identifier. Underscore. Okay. That's a cue to the reader of this program. Hey, there's a variable there, but he's not going to use it. It's such an unimportant variable, he didn't even bother giving it a name, or she didn't. Okay, so, yeah. This will go ahead and do this. Now can we make another object? Let's go, what was the next one we made in Racket? We made Marge, whose mother was, let's go. I'm going to go ahead and take the same thing, transliterate it. Then we're going to go back and make variables that hold some of these trees, just like we did in Racket. But let's go ahead and pause and type out the Java that corresponds to Marge, whose father is unknown, but mother is Jackie. Okay. After pausing, let's go back and just confirm exactly what you wrote. I want a new child, name Marge, 1955, I forget what that was. Blue, mother side, I'm copy and paste this right here. Copy. And new unknown. Getting a lot of right word drift here, aren't we? If I'm going to put one argument on this one line, maybe I should put all. Sure. Okay, so I think that corresponds to the Racket that we had in 1956. Now there's a few boring things we're going to have to do. We're going to have to write a constructor. A constructor for child. Do I need to write a constructor for unknown? Here's the one case where Java's default constructor is actually kind of the one I want. Java's default constructor does nothing, takes in no arguments, creates the object with totally uninitialized fields. I don't have any fields, so I don't need to initialize anything. Child, I need to make my own constructor that takes in 5 things and initializes each of them. How do you declare the constructor? You repeat the name of the class. Okay, string, what should I call the arguments that come in? I guess I could call them name, year of birth, YOB. That's kind of asking for trouble here. Oops, how did that? And I could do this, and then this dot name gets name. Yeah, okay. I think we may have been through this before already in a different example. This dot year of birth gets year of birth. Oh, how tedious. I wish my IDE could write this for me. I wish the languages do it for me. Come on, that's what I want. This is the obvious constructor. Hey, yeah, Racket's constructor did this for us, right? This dot ma gets ma. Do I need this dot? Well, certainly if I'm going to shadow the names, if I'm going to shadow the field name YOB with a parameter name YOB, yeah, I'm going to need to specify this. I'm going to go ahead. I think it's bad practice to use the same name, I think, for the parameter and the field because they're different things. I mean, this code works. It's correct. I'm just like, it's just asking for trouble. I'm going to use one thinking it's the field and it's not. So I'm going to go ahead and actually name my parameters starting with an underscore. And this is a pretty standard practice. And then my field names won't use the underscore. And now I could say just name gets underscore name. YOB gets underscore YOB. I think I mentioned Barlin's brain is too small to sort of say, hey, a field name may or may not be preceded by an object and a dot. And if it's not, then it's assumed to be a variable called this. And oh, you can't do that in a static method. Barlin's life is a little bit simpler. I'm like, you know, I'm always going to have an object dot method. I'm not going to have a method name without having an object and dot in front of it. So I'm going to write into this dot. You don't have to. I'm going to do it. And the reason is I like this nice, simple, consistent picture. So, okay, at this point, I should be able to go and compile my program. I have, and you know, here's the thing I don't like about putting this here. I have class AncTree, which is real easy. I have class child, which is real easy. Class unknown, real easy. And then I have this relationship between them. I can compile this and run it. By the way, the picture we'll end up with, we actually have 3 classes with relations between them. Some extending, that extends is really important, right? And the fact that we have that recursion, that a child, 2 of the fields, AncTree, are themselves, the ma and pa, those fields are themselves AncTrees. So I can go ahead and look at this. And this is the class diagram for that. Class AncTree, unknown extends AncTree, that's that solid arrow. Child extends AncTree. This dotted arrow is a has-a. So this is the is-a relationship. The solid line, dotted line is a has-a. I'm not big into the diagrams and remembering solid versus dotted lines and so on, but it's good to look at it and remember, you know, certainly understand has-a versus is-a. That's very critical. This, by the way, is called the composite pattern. So if you can go off and look at software design patterns, we'll talk about the composite patterns. It's to do exactly this thing we did in Racket with a comment. An AncTree is an unknown or a child. Same thing here. So, and notice that we're kind of getting a union type now. The only thing that's not, so I kind of was fudging a little bit when I said we couldn't do union types in Java. We have to, well, we can fake it by using objects in new classes. I can't go ahead in Java and say, hey, I want a union of a string and a child, or a string and an int. Why? Class string already exists. Class integer already exists. And small int, not even a class, so I can't really extend its type. So I can't make new union types involving primitives or final classes or, you know, whatever, things that I already extend from something else. But I can make my whole new class. And even if I wanted just a single, you know, number as one of my variants, I'd have to make a class that wraps that single number. But then I get it in Java, and I get it in the type system. This is what you have all been wondering, waiting for in some sense. You didn't like that, having that just as a comment. An AncTree is this or this. Now it's in the language, and Java understands that an AncTree is an unknown or a child. Yeah. Okay. We'll come back in a moment and start writing a method. I think the first method we wrote before was size. Go ahead and write a size method for these, and then start watching the next video. Awesome.